Welcome to Mattermosaic, piecing together the universe one discovery at a time. Today, we venture beyond the stars to uncover one of the greatest mysteries in all of science, the expanding universe. What does it mean? How did we discover it? And what could it reveal about the ultimate fate of everything we know? When you gaze up at the night sky, it feels eternal, quiet, still, and infinite. The stars seem frozen in their positions, as though the universe itself were a perfect, unchanging stage. For most of human history, that's exactly what we believed. The cosmos was thought to be static, a great celestial sphere that simply was without beginning or end. But in the past century, everything changed. We discovered that the universe is not still. It's moving. It's growing. Space itself is stretching. And the deeper we look into that expansion, the more astonishing and unsettling the picture becomes. The discovery of cosmic expansion. The story begins in the early 20th century. At that time, astronomers were only just realizing that the Milky Way wasn't the entire universe. Beyond our galaxy lay countless others, enormous collections of stars, gas, and dust scattered across the vastness of space. One of the first to explore this new cosmic frontier was Edwin Hubble, an American astronomer working at Mount Wilson Observatory. Using the world's most powerful telescope of the time, Hubble studied light from distant galaxies and noticed something strange. The light wasn't the same as the light from nearby stars. It was stretched, shifted toward the red end of the spectrum. This phenomenon, called redshift, occurs when light waves are stretched as objects move away from us, much like the changing pitch of a siren as it passes by. What Hubble found was astonishing. Nearly every galaxy appeared to be moving away from us. And not only that, the farther away a galaxy was, the faster it seemed to be receding. This was the first clear evidence that the universe itself is expanding. From Einstein to the Big Bang. At first, even the greatest minds resisted the idea. Albert Einstein's equations of general relativity actually predicted that the universe should either expand or contract. But he didn't believe it. He introduced what he called the cosmological constant to keep the universe static. When Hubble's discovery confirmed that the universe really was expanding, Einstein reportedly called his earlier assumption the greatest blunder of his career. That discovery gave birth to what we now call the Big Bang theory. The idea that the universe began as a single incredibly dense point and has been expanding ever since. Every galaxy, every atom, every moment in time, all trace back to that initial cosmic explosion. But the Big Bang wasn't an explosion in space. It was an explosion of space. Space itself came into being, stretching outward, carrying galaxies with it like raisins in a rising loaf of bread. When we look through our telescopes today, we aren't just seeing distant objects. We're looking back in time. Light from the most distant galaxies has traveled billions of years to reach us, allowing us to witness the universe as it was shortly after it began. The more we learn, the more profound the mystery becomes. The cosmic tapestry. Evidence of expansion. We now have multiple lines of evidence confirming that the universe is expanding. The first is galactic redshift, as Hubble observed. The second is the discovery of the cosmic microwave background radiation, faint heat left over from the Big Bang, discovered accidentally by Arno Penzias and Robert Wilson in 1965. That background glow is like the afterimage of creation itself, filling all of space with a whisper of ancient light. We also have detailed maps of the universe's structure, showing galaxies arranged not randomly, but in vast filaments and clusters, forming a cosmic web that stretches hundreds of millions of light-years across. This large-scale pattern matches the predictions of an expanding cosmos shaped by gravity and time. Everything we observe, from the way galaxies move to the light of the earliest stars, tells the same story. The universe is growing larger every second. What expansion really means. It's easy to imagine galaxies flying through space, moving apart from each other like cosmic ships sailing across an ocean. But that picture is misleading. It is not the galaxies moving through space. It is space itself that is expanding. Imagine dots on the surface of a balloon. As the balloon inflates, every dot moves away from every other, not because they're traveling across the surface, but because the surface itself is stretching. In the same way, galaxies are not racing outward through space. They were being carried apart by the expansion of space. There's no center of expansion. Every point in the universe sees every other point moving away. To an observer anywhere, it looks as though everything else is receding. This has a strange implication. If we reverse that process, we eventually reach a moment when everything was closer together. A single point of infinite density and temperature. That moment marks the beginning of space and time as we know them. The mysterious force behind it all. For decades, astronomers thought the universe's expansion might gradually slow down under the pull of gravity. But in the late 1990s, two teams of scientists studying distant supernovae made a shocking discovery. The expansion is speeding up. Something is pushing galaxies apart faster and faster. That something has been named dark energy, a mysterious, invisible force that makes up about 70% of the total energy in the universe. We don't know what dark energy is. It could be a property of space itself, a kind of built-in tension that grows as space expands. Or it could be something even more exotic, tied to forces or dimensions we can't yet detect. Whatever it is, it's rewriting our understanding of the cosmos, and it raises a haunting question. If expansion is accelerating, where will it all lead? Possible futures of the universe. Scientists have proposed several possibilities for how the story might end or continue. If dark energy remains constant, the universe will keep expanding forever. Galaxies will drift farther and farther apart until their light can no longer reach us. In trillions of years, distant galaxies will fade from view, leaving only our local group, the Milky Way and its neighbors, as lonely islands in a sea of darkness. Stars will exhaust their fuel, planets will freeze, and black holes will slowly evaporate. Eventually, the cosmos could fade into a cold, silent expanse, what scientists call the heat death of the universe. Another possibility, though less likely, is the Big Crunch, where gravity eventually overcomes dark energy, causing the universe to collapse back into itself. Everything would fall inward until it becomes infinitely dense once more, perhaps giving rise to another Big Bang, another beginning. A third scenario is even stranger, the Big Rip. If dark energy grows stronger over time, it could eventually tear galaxies apart, then stars, then atoms themselves, unraveling the very fabric of reality. Each theory paints a different destiny, but they all point to the same truth. The universe is not static. It has a story, a beginning, a present, and an unfolding future. The deeper meaning behind expansion. Beyond the physics, the expanding universe invites deeper reflection. Why does the universe exist at all? Why is it not static but dynamic? Still creating, still evolving, still stretching outward into the unknown. Some see this as evidence of randomness, a natural process with no purpose. But others see in it a profound beauty, a universe that reflects the very essence of creation. Expansion could be a cosmic echo of something greater, a signature of design that speaks of intention. Even the laws that govern this expansion, the precise balance of gravity, energy, and matter, appear finely tuned for life to exist. The more we learn, the more it seems that our universe is not merely a random event, but a masterpiece of order and possibility, our place in an expanding cosmos. The expansion of the universe also changes how we see ourselves. We live on a small planet, orbiting an ordinary star, in one galaxy among billions. Yet we are capable of understanding this vast cosmic drama, of measuring its growth, tracing its origins, and contemplating its fate. That ability to comprehend the universe may be one of the most extraordinary facts about existence. We are not just passive observers, we are participants in a story that began billions of years ago and continues to unfold through us. Every new discovery adds another tile to the mosaic of understanding. a reminder that curiosity itself is part of the design. This is Mattermosaic, piecing together the universe, one discovery at a time. If you enjoyed this, let us know in the comments and keep the journey going by watching our next video.